Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, today we'll be solving paper 2 of November 2020 attempt of AASL. So let's get started with the first problem. So we have to find the value of f of 0 and f of 20, right? Fx is given. So A1, f of 0, this will be like 11 root 0 minus 2 times 0 minus 11, which is negative 11. Second is we have to find f of 20. F of 20 is 11 root 20 minus 2 times 20 minus 11. Now we have to put it in a calculator. Minus 40 minus 11. This will give you minus 1.81, which is the answer to part 2. Now for part C, we have to find two roots of fx equals 0. For part B, we can just use a GDC, right? So we can just graph this 11 root x minus 2x minus 11 and see where we get the points of intersection with the x-axis. So to graph it, we'll open this simulator. So equation is 11 root x minus 2x minus 11. Okay, if we graph it, this is how the graph looks like, and one of the zeros is at 1.726. So this occurs at 1.726. This is the first root. Second root would be from the same graph. We just have to move. So yeah, here we have the second root, that is 17.52. X equals 17.523. So these are the two roots of this equation. Now next is we have to sketch the graph of fx on this thing. So it starts at minus 11. So we have 1 point here, right? Then we have a root at 1.726 approximately here. And then we have another root at 17.5. 17.5 is here. So approximately the graph, like from the GDC, it should look like this. Go up, right? Then go and go down like this. This should be approximately the graph, right? Now with this we are done with question 1, and we'll start with question 2. So we have to find the coefficient of x to the power of 6 in the expansion of 2x minus 5 to the power of 9. Okay, so we can just expand this. So first is 2x to the power of 9 plus 9c1, 2x to the power of 8, negative 5 to the power of 1, 9c2, 2x to the power of 7, negative 5 squared, and 9c3, 2x to the power of 6, negative 5 whole cubed. Now in this term, this is the term which contains the coefficient of, which contains x to the power of 6, right? So I can just expand this term and I'll find the coefficient. So 9c3, 2x to the power of 6, negative 5 whole cubed. So 9c3, using our calculator, this gives us 84. This is 2 to the power of 6 times negative 5 whole cubed times x to the power of 6. So if I simplify this, I'll get minus 672,000 x to the power of 6. Therefore, the coefficient of x to the power of 6, this will be negative 672,000. And that's the answer to question 2. Now moving on to question 3, we have to solve this integral. So okay, integral e to the power 4x plus c plus 6 dx. This will be equal to e to the power of 4x divided by 4 plus 6x plus c. That's the answer to part A. Now for part B, h prime x is this. So we have to find, and h of 1.5 is given as 105. So find hx. So hx would be integral of h prime x, which is integral of e to the power of 4x plus 6 dx. So hx finally is e to the power of 4x by 4 plus 6x plus c. Okay, and h of 1.5 is 105. So we can find the value of c from here. This is this is equal to e to the power of 4 times 1.5 by 4 plus 6 times 1.5 plus c. So from here, h of 1.5 is 105, e to the power of 6 by 4 plus 6 times this is 9 plus c. So from here, c becomes 105 minus 9 is 96 minus e to the power 6 by 4. So hx is e to the power of 4x by 4 plus 6x plus c is 96 minus e to the power 6 by 4. That's the entire expression and the exact value of hx, which is the answer to part B, and this is the answer to part A. Now that's all about question 3. Now moving on to question 4. So we have a discrete random variable x. The distribution is given. So first we have to find the value of k. So for part A, we can probably prepare a table. Yeah. When x is equal to 3, it is 3k over 20. When x is equal to 5, it's 5k over 20. When x is equal to 8, it's 8k over 20. When it's equal to 11, it's 11k over 20. Now, if I add up all the probabilities, this should sum up to 1. So 3k by 20 plus 8k by 20, 11k over 20. This should be equal to 1. So if I combine the numerator, I'll get 5 plus 3 is 8, 8 is 16, 16 plus 11 is 27. So 27k by 20 is 1. So k is equal to 20 over 27. That is the answer to part A. Now for part B, we have to find the expected value Ex. So the page here, yeah. So Ex would be summation of x times Px. Okay. So first x is 3, Px is 3k times 20. So 3 times 3k by 20. Then x is 5 and Px is 5k over 20. So 5 times 5k over 20. Then we have 8 times 8k over 20. And then we have 11 times 11k over 20. Fine. Now, if I just simplify this, 9k over 20, this. Okay, if I add up the numerators, so 25 plus 9 plus 64 plus 121. 209, so 219 by 20k. And lastly, I can plug in the value of k in here, which is 20 over 27. So 20 will get cancelled out. So 219 over 27. I can divide 219 with 3. Give me 73. So this is basically 73 over 9, which is the final answer of part B. And this is the expected value of this probability distribution. Now moving on to question 5. Yeah. So we have this following diagram that shows the cross section of a roof of a house. It's symmetrical about symmetric about AE. Gradient of BA is given as 7 over 12. You have to find the size of BAE. Okay. Now if I draw a line, if I draw a straight line, okay, this angle, okay, and I can do one thing, I can extend the line from AE. Okay, this will be 90 degree. Let's say this angle is theta and this angle is alpha. Okay, so BAE is technically this angle alpha, right? So I know tan theta, gradient of BA is given as 7 over 12. So tan theta is 7 over 12. Yeah. So from here, theta would be tan inverse 7 over 12, which is 30.26 degrees, right? Now we have to find angle alpha. So angle BAE, which is equal to alpha, is 180 minus 90 minus theta, which is 30.26, which gives you 59.74 degrees. This is the answer to part A. Yeah. Now we have this, a builder requires the length BA and CE. The builder has the following measurement: ABC, okay, ABC. This angle, okay, these two are 90 degrees, all right, this is given. DC is 50, okay, BC is 30, B to C, okay, this length is 30, and DF is 700. This entire thing is 700, okay. So we have to find the length CE, okay. So first we have to find this length CE. Okay. Now to find CE, okay, I can make a triangle here actually. Yeah. Okay, so here is this triangle. So okay, yeah, this angle will be same as theta, so this angle is 30.26 degrees. Okay, so all right, now if I look into this smaller triangle, okay, this length is 50, this angle is 30.26. okay, so I can find this length B. B is basically this the base length. Okay, so in this small triangle I can say cos 30.26, this is B over 50, and from here B would be 50 cos 30.26. This is 43.2 centimeters. So just this much length is 43.2 centimeters. Okay. Now this total base length from here to here, this will be, see, this one is 43.2, right? And this part is half of 700, so this part should be 350. Yeah. So this part here is 700 divided by 2, which is 350 centimeters. Okay. So total base length, this would be 350 plus 43.2, gives you 393.2 centimeters. That's your total base length. Now we have enough information of this triangle. So this angle is 30.26, entire base length till here is 393.2. So we can find the hypotenuse from here. Okay, just need to take cos of this 30.26. Therefore yeah, the cos 30.26 for the bigger triangle, this point is O. Okay, this would be CE. No, this is based by hypotenuse. So CO divided by CE. CO is 393.2, and then CE, which is the required length. So what we have to find. So CE would be 393.2. Divided by cos 30.26. Which is 455.2. That is the answer to the first part. So CE is 455.2 centimeters. Next is we have to find the length BA. Okay, so I know the length of CE, right? From CE actually, if I drop a perpendicular on this line BA, this length will be equal to this length. Okay, we just have to find this small section here, this length. So this point is P. Okay, so this length is 30, so this length will also be 30. Okay, and I know this angle, this angle we have found in the first part, that is this angle alpha. So this angle is 59.87, 59.74. Okay, 59.74 degrees. I need this length PE. Okay, so second one, PA would be, wait, for PA, we can use tan theta. Yeah, so tan 59.74, this is basically 30 divided by PA. So tan of this angle will be opposite over adjacent. Yeah, so from here we have to find the length PA, which is 30 divided by tan 59.74. This gives you 17.5 centimeters. Now the length BA would be CE plus this PA. CE plus PA, which is CE is how much? It is 455.2 and PA is 17.5. So gives you 472.7 centimeters. And that's the answer to the last part of this question. Yeah. Now we have this question 6, where we have this function hx equals log base 10 4x squared minus rx plus r minus 1. Yeah, so we have to find the possible values of r. Now, if I check, this is a quadratic inside, right? Inside log. Now this thing cannot be equal to 0 or cannot have a negative value, right? So if I try to draw this parabola, right, it would look something like this, maybe somewhat like this. Yeah, it should not cut the x-axis, and the minimum point of the vertex should be above this x-axis, right? Because if it cuts the x-axis, first thing is it will become negative, right? If it just touches x-axis at a point, then log base 10 0 is again undefined. So this has to be greater than 0. Okay, so 4x squared minus rx plus r minus 1 has to be greater than 0. Okay, now if I take it as a quadratic, so a is equal to 4, b is equal to negative r, and c is r plus 1, right? So here, as we don't have any roots, the discriminant has to be less than 0. Okay, so I can do one thing, I can do d less than 0, which is b squared minus 4ac. So as discriminant is less than 0, it will not have any real solution. So this parabola will not cut the x-axis. So minus r whole square plus minus 4 times 4, c is r plus 1. R squared minus 16r minus 16, this has to be less than 0. Okay. Now we have to solve for the values of r. So first, to solve this, we can do one thing, or we can do just plot this on our TI, and I will get the intervals. So it is like, instead of r, I'll take x, of course, x squared minus 16x plus 16. Yeah. Oh, this will be 1 second, this will be r minus 1. So plus 16. Yeah. Now if I graph this, so yeah, so r has to be less than 0, right? So we have to find the interval where this r is negative. So it is negative between, like, negative as in below the x-axis. Yeah. So we have to find the zeros. So in between these two zeros, your r is, the discriminant will be less than 0. So first zero is 1.0718. Okay. Okay, and the other value would come from here, which is 14.93. So these are the possible values of r. Okay, and that's it. That's the answer to question 6. Yeah. Now we'll move on to section B. Yeah, so here we have 3 big questions. Let's start with question 7. So My Life is a social media platform with 93.6 million users, all aged 13 years old and above. So the frequency table is also given. So you have to find the percentage of My Life users aged 45 years or older. Okay, 45 or older is basically these two. Okay, so 45 to 65 is 17.3 million and 65 to 85 is 3.7. So for part A, so we'll do percentage users aged 45 years and above, this will be 17.3 plus 3.7 divided by the total number of users, which is 93.6 million, times 100. So this should give us 22.4%. That's the answer to part A. Okay. So if we look at it, right, so kind of this looks like a normal distribution. You see, a small values here, it goes up and goes down. Okay. So sample of 1000 MyLife users are chosen at random. Find the probability that fewer than 200 of them are aged 45 years or older. Okay, so we can assume it to be a normal distribution. Okay. My mu is n times p, 1000, and probability of someone aged 45 years or older is 0.224 from part A, which gives us 224, right? And sigma is mu np 1 minus p, root under 1000, 0.224, 1 minus 0.224. If I plug it in a calculator, I'll get 13.2. Okay. So now we have to find p of x less than 200. Okay. So if I do the left tail test, I'll get the value as 0.0345. That's the answer to part B. Okay. So this comes from your calculator. Yeah. Now the next one. Given a MyLife user is chosen at random at 45 years or older, find the probability that they are 65 years or older. Okay, so for this we can just use the conditional probability that age is greater than or equal to 65, well, given that the age is already greater than or equal to 45. Okay, so probability of someone whose age is greater than 65, like the number is 3.7, and the total number here is 3.7 plus 17.3. Total number of people who are aged, like, you know, above 45 and 65. So this will give me 0.176, which is the answer to part C. Now for part D, we have to list the mid-interval value for each class interval. Mid-interval value, okay, I can just make a column here. This is the mid value. Okay, between 13 and 18, to find the mid-interval, I'll just add 13 and 18 and divide it with 2. So 13 plus 18 divided by 2 is 15.5. That's the first mid value. Similarly, for the next one, it will be 21.5. Next one is 35. Next one is 55. And the last one is 75. These are your mid values for each class interval. So we are done with the first 4 parts of this problem. So 9 marks out of 14 has been solved. Yeah. Next, for the MyLife users, we have to estimate the mean age and the variance. Okay. So first one, mean would be summation fx divided by summation f. 15.5 times 5.5. Okay. So we are multiplying the frequency with the mid values on the numerator. Okay. So frequency times mid value, 5.5 and 15.5. Yeah. So in this way we'll go. So 23.6 times 21.5, then 43.5 times 35, then 17.3 times 55, and lastly you have 75 times 3.7 whole divided by the total frequency, which is 93.6. If you simplify, you'll get 35.7. That's your mean age. Okay. Second thing is we have to find the variance. Variance is summation of fx squared by summation f minus mu squared. Okay. Now to solve this, (55 squared), then 3.7 times 75 squared divided by 93.6 minus 35.7 whole squared. This should give you 197.8. So this is how you'll find the mean and variance of the ages. Now for the next part, so we have another social media platform called Smalltalk. Reports that its users have a mean age of 29.9 and variance of 137. So for Smalltalk, mu is 29.9, variance is 137. Okay, and for my life, yeah, mu would be 35.7 and variance is 187.8. So yeah, mu is this 35.7 and variance is 197.8. Now higher variance means a lower height, okay, and mu bigger means it will be like being shifted to the right. So one of them we have to identify a curve whose height is low and shifted to the right. Height low, shifted to the right, so it is big. Okay, so here if I check this solid line, this height is smaller than that of the dotted line, right? And the midpoint is shifted to the right as compared to the left one, so I'm pretty sure C is the answer here. Okay, if you see, if my life is the solid and the solid line here, okay, is my life, yeah. This is because for the solid line, you see, for my life, mu is bigger than that of Smalltalk, right? So Smalltalk has a lower value of mean as compared to my life, because the my life's midpoint is lying to the left of that of the of Smalltalk, yeah. And if I compare the heights, my life has a smaller height as compared to Smalltalk, and that is true because higher variance will have smaller heights. So C is the right answer, with the solid line being my life. Now moving on to the next one. So we have the following table which shows the population of Canada T years after the year of 2000. Okay, so T and P, the data is given. So first we have to use the linear regression model to model the population of Canada using the data P equals 80 plus B. Okay, now if I use the regression calculator, you will see that A is 0.358 and B is 30.52. Okay, now second is we have to find the value, or like interpret the value of A. So if you look here, it's A is A times T plus B, right? So A is the average yearly increase of population in millions. Okay. Now the student uses this model to predict the population of Canada in the year 2030, where T is equal to 0, and calculates the population of approximately 41.3 million people. So we have to comment the reliability on the student's prediction. Now the thing is, we are using a linear model here, right? And linear models are actually pretty simple models, and they they cannot be applied over larger periods of time, because if T becomes huge, what happens is the population also will become huge, which is kind of not true. Okay, so to comment on it, I'll say linear models are too simplistic over longer periods of time. This is because your population growth can either speed up or slow down in this meantime. Okay. Good. Okay. Hence, the prediction is not reliable. Okay, that's all about part A and B. Yeah, then try part C. A data scientist Benioff uses additional information to develop an exponential model for Canada's future population. So this is the equation, Benioff's equation. 33.5 times 1.005 to the power of T represents millions of people, the millions of people in Canada T years after the year 2000. So T should be, they have also restricted that T should be in between 25 and 100, right? So using this model, we'll predict the population of Canada in the year of 2100. Okay, so C1, so we have to find B of 100. Okay, 100 years after 2000 of 100. Now, if I put it in a calculator, I'll get 55.16 million. That's the answer to the first part. Second, interpret in context the value of 1.005 in Binomial's model. So, 1.005 is the annual growth factor in this model. Now, which corresponds to say 0.005, like the fraction is increasing by 0.005, so which becomes 0.5% increase to a 0.5% yearly population growth. That's all about this part C. Now, in this last part, so Cecilia is another data scientist. She forms a third model, which looks like this. So this is called the logistic growth model, and logistic growth model technically is like kind of the most accurate in like within these three models, right? So first we'll use Cecilia's model to predict the population of Canada in 2100. Okay, so C of 21, C of 100. One plus e to the power minus 2, which is 54.61 million. Okay. Now determine the year in which difference between predictions from Benioff's model and Cecilia's model is the greatest. Okay. We can do one thing, we can find the difference function. Okay. Difference function will be 62 divided by 1 plus e to the power minus 0.02 t minus 33.5 1.005 to the power of t. Now we can plot this on our TI and find the time where the difference is the highest. Okay. So yeah, you can do one thing, I can clear this thing. So 62 divided by 1 plus e to the power of minus 0.02 x. Okay. Power of x. Okay. Yeah. Closing the bracket, minus 33.505 to the power of x. Okay, if I try graphing this, I'll get something like this. Okay. Now we have to find the highest or maximum value of y in this thing. Okay. So here is the maxima, I guess. Yeah. Maxima is at x equals 58.62. This is the point where the difference is the highest. So 58.62. So it's 2 years. Okay. 0.62. We have the maximum value of the difference. Hence, t equals 58 years. This will be the answer. Okay. Yeah. And the next part, you have to find b prime 75 and c prime 75, and we have to interpret the values. B prime t would be 33.5, 1.005 to the power of t ln 1.005. Okay. Now b prime 75 Okay, so this should give us 0.243. That's b prime 75. Next is we have to find c prime t first. It'll be okay, 62 divided by 1 plus e to the power minus 0.02 t. We'll first square this, then differentiate the denominator, keeping the numerator constant, minus 0.02 t times, and then this the differentiation of this thing would be minus 0.02. Okay, so c prime t finally becomes 1.24 e to the power of minus 0.02 t 1 plus e to the power minus 0.02 t whole squared. Okay, now we have to find c prime 75. E to the power minus 0.02 times 75 whole squared. Now if we put it in a calculator, that will be 1.24 e to the power minus 1.5, 1 plus e to the power minus 1.5 whole squared. This will give us 0.185. Okay, so that is c of 75. Now next, which is the last part of this question, that is we have to compare and interpret in context the values of b prime 75 and c prime 75. Okay, so so the Benoit's model predicts a growth rate of 0.243 million per year at t equals 75 years, which is the year 2075. Whereas Cecilia's model predicts a lower rate, or say lower growth rate, of about 0.185 million per year. And that's it about this question. Yeah. Now coming to the last question. So here fx is given as 6 cos pi x. We have to first find the amplitude of f and the period of f. Amplitude is basically the number which is multiplied in front of the trigonometric function. So amplitude in this case will be 6. Now period, we can find period by this formula 2 pi over b, where b is the number which is multiplied to x. So in our case b is pi, so 2 pi over pi, so period is basically 2 seconds. Fine. Now we have a second function gx which is equal to minus 8 sine pi x. So some of these functions can be expressed in the form fx plus gx equals a cos b x minus c, where abc everything is positive. You have to find the value of ab and the smallest possible value of c. Starting with 1, yeah. So here if we are doing 6 cos pi x minus 8 sine pi x, your amplitude would be, so it'll be 6 squared plus minus 8 squared, which is root 36 plus 64, which gives you root 100, which is basically 10, right? Now second, the period, b. So here for both fx and gx, pi is multiplied to x, so b will also remain as pi. Okay. For the third part, we have to find the smallest possible value of c. So for this, we can start the problem like this. So 6 cos pi x minus 8 sine pi x, this can be written in the form 10 cos pi x minus c. Okay. Now if I expand the pi, cos, this cos pi x minus c, I can also write it like this. I can write it as pi x minus pi c. Fine. Now I can expand this cos pi x minus pi c. So cos a minus b is cos a cos b plus sin a sin b. I can use this formula. So 10 cos pi x cos pi c sin pi x sin pi c. This is equal to 6 cos pi x minus 8 sin pi x If I expand this thing, so you see the number which is multiplied to cos pi x is basically 10 cos pi c. Number which is multiplied to sin pi x, this will be 10 sin pi c, which is equal to cos pi of x minus 8 sin pi of x. Right? If I compare both terms, like like cos pi x and this thing, so number which is multiplied to cos pi x should be equal to 6. So the constant which is multiplied here should be equal to the 6 on this side. So 10 cos pi c would be equal to 6. So cos pi c would be equal to 6 over 10. Similarly, if I compare this 10 sin pi c to minus 8, I'll get 10 sin pi c equals negative 8. So sin pi c would be equal to negative 8 over 10. Fine. Now, we have to find the quadrant where cos is positive and sin is negative, which is basically your fourth quadrant. So we'll basically find the solutions in the fourth quadrant. Okay. To do that, first let's find the principal solution using cos pi c. So pi c, cos inverse 6 over 10. If I use my calculator to solve this, I'll get 0.927 radians. Right? But 0.927 radians is in the first quadrant, so I have to shift it to the fourth quadrant. So fourth quadrant will be 2 pi minus theta, which is 0.927. So pi c would be equal to this is 5.356. So c is 5.356 divided by pi, which is equal to 1.705. This is the minimum value of c. Now we are done with this part. The next part, we have a car. A car is traveling along a straight residential street with speed bumps placed at regular intervals in the road to encourage safer driving. The car travels at a minimum velocity when passing over the speed bumps and reaches a maximum velocity in between the speed bumps. Right. So this is the equation. Minus 4.5 cos pi over 19 t minus 4 plus 10.5. First reaches its maximum velocity. So maximum velocity of the car, this will occur when the cos component, right, this cos component should be equal to 1, right, I mean negative 1. So max velocity is basically 4.5 plus 10.5, which is 15 meter per second, which occurs when cos of pi over 19 t minus 4, this thing is equal to negative 1. So cos theta becomes negative 1 first time at at pi t minus 4. This is equal to pi. Yeah. Okay. So t minus 4 would be equal to 9. Like it will be 19. Yeah, because pi's will get cancelled out. So t would be equal to 23 seconds. This is the first time the car reaches its maximum speed or maximum velocity. He's done. We'll find the number of speed bumps the car passes in the first 2 minutes of motion. Okay. So for this thing, we'll first find the time period. Time period of this car will be 2 pi divided by the number which is multiplied to x, which is multiplied to t, which is pi over 19 in this case, divided by pi over 19. On simplification gives you 38 seconds. Okay, so in 38 seconds, the car completes one full cycle. So basically, it passes over one speed bump. I can write it like this. The car completes one full cycle, which is one speed bump pass every 38 seconds. Okay, number of speed bumps, this is equal to 2 times 60 over 38. Finally, this becomes 3.16. Okay, so basically we can say the car passes 3 speed bumps in 2 minutes. That's part D. Now for part E1, we have to find V prime t. We just have to differentiate this thing. So start a page here. So V prime t would be minus 4.5. Differentiation of cos is negative sign. The inside part remains the same. Yeah, and then we have to differentiate the inside part, which is pi by 19 t minus 4, which upon simplification gives me, so negative cancels out, so it's 4.5 pi over 19 sine of pi by 19 t minus 4. This is your v prime t. Now a max, so a acceleration is equal to v prime t, right? So a max is basically the maximum value of v prime t. Maximum value of v prime t occurs when the sine part becomes 1. This is equal to 4.5 pi by 19, okay, times 1, because max value of sine x equals 1. This upon simplification would give me 0.744 meter per second, which is the answer to my part 2. Yeah. So E1 and 2 are done. Now the last part, we have to find the distance between two consecutive speed bumps. So we can so two consecutive speed bumps is like if I draw a curve like this. Yeah. Two consecutive speed bumps means I need to find the like the wavelength, basically, like the distance covered between this point and this point, which is basically the distance covered in one time period. Fine. So for part 2, part F basically, right, we can find the displacement. So let's try to graph this on our calculator and see how it looks like. So yeah, this is a graph which I have plotted, minus 4.5 cos pi over 19 times t minus 4. If you look at the graph, the minimum occurs at x equals 4, right? And the next minimum occurs at 42, right? So between these two minimums, you have two speed breakers, one at x equals 4 and the other one as 42. So we'll try to integrate between 4 and 42, the entire vt function, to get the distance between the speed bumps, right? So the displacement equation would be integral of 4 to 42 vt dt, right, which is integral 4 to 42 minus 4.5 cos of pi over 19 t minus 4 is 10.4 dt. Now if I put this in a calculator, right, I'll find the value as 395.2 meters, which is the answer to part F. And with this, we are done with this paper. And next I'll be posting the papers of HL Maths. So yeah, thank you so much. See you in the next video. Bye.